So, hello student, today we will continue the model 2 sources, types and characterization of solid waste. So, in the previous class we talked about different sources and based upon the different type of solid waste. Now, today we will continue the same module based on sampling and characteristics of solid waste. So, this is most important discussion before discussion about collection, treatment or disposal, and characterization is very important, and along with the sampling also is very important. Like for water and wastewater, we need not to understand much about the sampling. Most of the students in the colleges, they take it the drinking water bottle for collection of water, wastewater, because it is a homogeneous most of the cases. And if you collect the water samples or even wastewater samples from different areas, I think most of these are homogeneous sampling and very easy to collect. But for solid waste is a highly heterogeneous waste. So, very difficult for the sampling as well as characterization. So, normally sampling we do by the quartering method. This method is given by NERI, National Environment Engineering Research Institute, Nagpur. This method called as a quartering method. So, normally sampling should be done in the 4 season, whatever the 4 season in the entire year. So, is a sampling itself is a very difficult for solid waste. If you want to understand the entire different type physical or chemical characteristics of the solid waste, need to collect sample from the 4 seasons, and normally in a week entire 7 days, because weekdays and weekends are different way the waste is getting produced, and at least twice in a season. So, that the characterize sampling itself is a very difficult. If you locate, if you want to do the characterization study for the city, you locate out the different location, and this entire area also is segregated by high income group, low income group areas, commercial areas. These kind of different locations you can find it out, and in that location collect the waste. I give one example. Suppose 100 kg of waste, we put it like this, and now we will go for the quartering method. With the entire waste we will quarter in the 4 quarters, and these 2 quarters we will again put it in the same way, is a 15 kg waste, and likewise we will go by quartering the different waste, and we will get finally almost 10 to 20 kg of waste, that is a sample final. And from that the we will grind it, like this waste we will dried it, grind it, sieve it, and which will go for the chemical analysis, and final the same waste will go for the physical analysis. This is the way we can collect 10 to 20 or 15 kg of waste, that will be your sample. And the major idea about the quartering method is a need to get it the homogeneous waste, not heterogeneous waste. So, that and number of samples could go up to 10 to 30 different numbers of samples from the different locations. So, now first we will talk about the physical analysis, and after that chemical analysis. So, in physical analysis normally we do the composition analysis. We know that the waste is separated different physical properties such as dry, wet waste, how much amount of paper, plastic or different kind of waste is available. This normally this composition analysis we will do by manually, we will weight it and reference by the fractions of the total waste. This is very important for the selection and operation of the equipment, facility and disposal facility. Suppose without knowing the composition of different waste, physical composition like wet waste, very difficult to design the composting plant or biological treatment plant. And suppose if you are planning for the incineration facility, and if you do not know the how much amount of combustible matter, and majorly combustible matter like paper quantity, plastic quantity, rubber quantity, these very important combustible materials which required for the incineration facility. So, for the not only treatment process but also for the disposal facility, need to know the how much amount of leachate is getting produced, or what kind of waste is available in the entire what kind of waste is coming to the disposal site. Based on that we can design the disposal facility. We will give one example. This is one study has been done by the CPCB in 2000, municipal characteristic of few cities in India in 2000. If you see this entire data, you will see the paper and plastic quantity is very low. You see the plastic quantity was in 2000 was 3%, 2% and very small quantity. Paper quantity is also at maximum 10%. But if you see the inert quantity and the biological quantity was more than 40%, 50% most of the cities, and even the inert content, which is not the dry and wet, is a different, the soil content, more soil content, that was the very high, was around 50%. If you see the another cities like the other cities also, like in Madras 10% paper quantity, plastic is only 3%, inert content is 33% and biodegradable concentration was almost was more than 50%. But if you see in the this is another report by the Planning Commission in 2014, if you compare with this data with the 2000, you will be surprised that the plastic quantity was very 3%, 1% was increase in the 2000 was more than 10%, and even the inert content was very high in 1996 or around 2000, what 45% was reduced to the only 17%, and but see the very surprisingly the biodegradable quantity was 42%, 47% and even in 2011, 2014, 15, 42%. Still currently in 2020 also you see that the biodegradable fraction is almost 50% and the paper and plastic quantity was increased to the 15 to 20% and inert content was reduced to 30%, 35%. One more waste is added, construction and demolition waste. That quantity with the day, with the industrialization and developing into the city, that quantity is also increasing now. This composition variation is depend upon the different parameter, like first is the location. So, is the location wise what kind of a commercial activity in that particular location, and simply with the plain areas and hilly areas, these compositions, entire physical composition will change. Even in the warm and cold area, these physical compositions are getting changed. And the season, now that is why when I talked about the sampling, I said about that the sampling should be in the different season, because the season wise the entire waste or commercial facility, commercial materials also availability is different. So, the season also is one of the important parameter to know about the different composition of the solid waste. Now, another the economy. So, that is why when you do the sampling, I asked you about if you collect the sampling from the city area, we need to entire area has to be separate into the high income group, low income group and commercial areas, market areas, vegetable markets. So, that based on that, with the time and with the economy is getting changed different waste compositions. So, it is very important to know about the waste composition. So, when you are planning for the sampling also need to be planned every after 10 years, 15 years, you need to do the sampling and to know about the different physical compositions are changing with the time. So, to design the recycling facility or any disposal facility. Now, the another parameter in the physical characterization is a specific weight or density. This very important to know about the how much volume. I think normally when you talked about the solid waste, we normally talked about in the weight, but the volume is also very important to know about how much area will be required into the disposal site. So, that in the disposal site how many land will be required. For that we also need to know the what will be the density or the volume of the solid waste. And this specific weight or density is calculated by weight by volume. Normally in India or the developing countries have very high density waste that goes to 400 to 600 kg per meter cube, is because of inert content, more inert content, And more I also told about the construction and demolition waste. That is also because of that we are getting very high density of waste. So, if more density means your collection facility will be different based on that. This is one of the data for the specific weight values of the different Asian countries. Of mostly the Asian countries, if you see that the food waste, especially for the food waste, the density is very high. Likewise, for paper and plastic, the density is very low, like just 100 kg per meter cube. So, is also changing with the different season, because the compositions are changing, the based on the composition density will also change. Another parameter called particle size. This parameter normally is important for the recycling facility, because there we need to know the what kind of size. Even for the degradation process also we need to know the particle size. There are different ways of calculation of particle size, like there are different ways by based on the length and width or height of the that particular material. So, and these are the few machines normally or equipments we use to separate out the different size of the particle, like this is trommel. This is simply one of the another trommel screen. This is magnetic separator, like here once another magnetic separator. So, from that the magnetic particle is getting separated from the main waste. So, this is another physical parameter is the field capacity. This field capacity is the total amount of moisture that can be retained in the waste sample subject to the downward pull of gravity. This parameter is very important to know about the how much leachate is getting produced once the waste goes to the disposal site. So, is a excess of the water in excess of the field capacity will be released as leachate. Normally, this analysis I think you can understand by this photograph. The solid waste once the rain onto the disposal site will get the leachate production, that is called as the field capacity. So, I will show you some of the photographs. So, these are the leachate, is the leachate produced after the rain onto the solid waste. This is also one of the photograph where leachate. This normally if you know this quantity before the waste goes to the disposal site, will be able to design the collection facility and treatment facility of the leachate. Now, the chemical characteristics. This chemical characteristic is very important especially for the treatment process. Now, the first is the proximate analysis. Proximate analysis normally analyze to know about the combustion property of the solid waste to design the incineration facility or combustion facility of the solid waste. Normally, to analyze the 4 parameter, the first parameter is the moisture content. Moisture content normally is analyzed by 104 degrees centigrade in hot air oven for 24 hours. Normally, this moisture add weight to the waste without increasing its heating value. So, once the way you are designing for the incineration facility is very important to know the moisture content. If more moisture content will be required, so more is unnecessary adding the weight into the waste, and there will not be any increase in the heating value with having the moisture content into the waste. Another parameter called ash, this analyzed at 550 degrees centigrade for 2 hours in the open crucible is analyzed, and this is also added the waste without releasing any heat into during the combustion process. This is also very important parameter. After combustion, if the waste is producing large amount of ash, it is very difficult to dispose about such kind of ash material. Another parameter, the third parameter is a volatile matter. This is also analyzed by 700 to 950 degrees centigrade in covered crucible. Volatile matter is a portion of waste that convert to gas before and during combustion. This is the very important parameter for the combustion facility. If for incineration facility, if more volatile solids are there, more will be the heating value of the waste, more energy could be possible to produce. So, another parameter is a fixed carbon. This fixed carbon represent the carbon remaining onto the surface of the grate where the waste is getting incinerated in the incineration facility as char, and this is unnecessary waste is getting produced in the while combustion of the solid waste. Normally this fixed carbon is calculated by all these 4 parameters should be 100%. So, you are able to calculate the moisture content, ash content, volatile, and also we can calculate the fixed carbon. If more fixed carbons are there in the waste, very difficult to go for the combustion facilities. This is one example about one study has been done for Jalandhar city in the Punjab by few authors. You can see here the proximate analysis of different high income group, middle income group and low income group areas, and you see the data of volatile solids. Volatile solids data for high income group is 25%, middle income group 19% and low income group is 18%. So, with the different areas, we did the sampling in the different areas. Based on that, your entire the proximate analysis is getting changed, and you see the fixed carbon 6.9, 7.2, 8.1. It is getting increase in the low income group area compared to the high income group area. Similarly, the moisture content also is very low into the high income group area and more into the low income group area. Likewise, with the different areas, the different proximate analysis will understand what will be the, even you see the calorific value of the waste is getting changed in the different area. So, this is another data of Bhopal where you will see the volatile solid is 46% and moisture content is 28%. So, based on that we can understand the whether waste is able to get combustible or can go for the combustion facility. Now, the ultimate analysis. Normally, the ultimate analysis of the waste is carried out to determine 5 different parameters like carbon, hydrogen, oxygen, nitrogen and sulfur. These are the 5 components normally analyzed for the waste to know the ultimate analysis. So, these data like here, if you know the hydrogen concentration is very good for the combustion facility, even carbon concentration is more very good for the combustion facility. If you know the nitrogen concentration is very good to know the biodegradability of the waste, or if you want to design the composting plant, anaerobic digestion plant, if you know the carbon to nitrogen ratio, that is very good for the designing of such kind of biological treatment facilities. And it is analyzed by CHONS analyzer. There is a one particular instrument where we can analyze these 5 different components. So, for example, again we got some data for carbon, hydrogen and sulfur. If you see here the hydrogen concentration is 3%, 3%, 4% hydrogen concentration, and carbon concentration is 27 to 29%. So, based on that we will come to know here nitrogen also 1.21% is good for the degradation facility. And this is another data where carbon concentration is 26% and nitrogen is 47.7%, means more waste is good for the biological treatment facility. Now, is another parameter called energy content or calorific value. This is normally designed by full scale boiler as in calorimeter, or laboratory one bomb calorimeter. This is one small diagram of the bomb calorimeter. In a vessel the waste is getting combusted, and normally this energy content we calculated by this formula having the concentration of carbon, hydrogen, oxygen, sulfur and nitrogen. But in India we analyze by the bomb calorimeter, and in India we analyze the energy content measured in kilocalorie per kg unit. This is one unit we are using in India, kilocalorie per kg. So, 1 joule is equal to 0.24 gram of calorie. So, just for understanding. So, this is some data we collected from CPCB NIRI 2016, where they characterize the entire waste based on the different population of the city. So, cities with population less than 1 lakh, the calorific value is 2149 kilocalorie per kg, and with the moisture content 52%. Like if you compare with the same, the cities with population is above 40 lakhs, your calorific value is less 1772 and moisture content is 47%. So, if you see the entire data, calorific value is very high, maybe because of paper and plastic or combustible matter, but because of more food waste, more biological matter, the moisture content is very high, is 47-50%. So, such kind of waste is very difficult for the combustion facility. So, is good if it is getting segregated, the biological waste will go to the composting plant and the dry matter will goes to the combustion facility. That is the best thought from this kind of data. So, another table you see that it was given by International Solid Waste Association in 2013, the different fraction of waste, what will be the net calorific value. If you see the paper, plastic and textile have very high net calorific value, but if you see the organic material is very low concentration, it's just a 900 kilocalorie per kg. So, such kind of waste is not good for the combustion facility. If you get separated like paper, cardboard, plastic, textile, this material is highly combustible, will easily get net calorific value more than 3000 to 5000 kilocalorie per kg, and metal and glass do not have any calorific value. Now, another parameter is the metal content, also is very important to analyze once the waste goes to the disposal site. Once the leachate is getting produced in the disposal site, these metals is adding into the leachate and getting polluted the groundwater. So, for that also very important to know the metal analysis. This analysis normally we do by atomic adsorption spectroscopy. This also I think because it is a solid material, the powdered material, the dried grinded powder material has to be digested and converted into the liquid sample and get it analyzed by atomic adsorption spectroscopy instrument. Now, the biological characteristic, this is one of very important characteristics also to know that the biodegradable fraction of the solid waste. This normally we do by volatile solids, the same way, the way we analyze the solid waste for solid volatile content. This is not the exact indicator of the biodegradability, but if you know the volatile quantity both way, for the incineration facility and for biological treatment facility, both this parameter is very important. Just for one example, like paper, print newspapers are highly volatile matter, is very good combustible material, but it is not biodegradable, is a highly volatile, but is not biodegradable. So, is need to be understand that both the datas are not same, like every volatile materials are not biodegradable material, but every biodegradable matters are the volatile in nature. So, I think for this paper and plastic, even plastic also volatile matter, highly volatile matter is, but is not degradable matter. So, for degradable fraction we normally analyze by one equation, like biodegradable fraction is 0.83 minus 0.28 lignin content. So, if you know the lignin content of the waste, is easy to calculate the biodegradable fraction of the solid waste. If you see the one particular data of India, the percentage of MSW of the different data, like food waste is 10%, glass is 5.5%, plastic is 9.5%, but the biodegradability of this particular percentage is very low, except the food waste having 10% in the MSW is having the 0.82% of the biodegradable fraction. So, and this yard trimming is also highly biodegradable. So, from this we can easily understand how much is the biodegradability of the particular fraction. So, another few more parameter, normally we never analyze such parameter, but need to understand that the breeding of flies, normally it will take the 1 week to 2 weeks once it is getting stored at particular location. This is very important to know while designing the dustbins inside the city. If waste is getting stored for the longer period, I think breeding of flies is possible in such kind of locations. And odor also, this is very important. This odor normally is come from the two major gases like methane and ammonia gases. Normally methane is very low concentration of methane is getting produced, but ammonia because the waste contain lot of biodegradable matter, so nitrogen content is very high, and this organic nitrogen is convert in the during degradation process or anaerobic condition, this organic nitrogen is converted into ammonia, and that create the odor issue. So, thank you. So, with these characteristics, we will easily understand the different characteristics of the solid waste. Based on that, we will be able to design the collection facility and also treatment facility. Yeah, thank you.